Hello. I want to talk really briefly today about the join operation in relational algebra. Uh, this is as it is in the book, and it's quite simple actually. This is this bow tie operator with its predicate, and we're just using theta here to represent the expression that you would write there in place of that. It's not that you're going to write a bunch of thetas all over the place. So basically, so in this would be some Boolean expression, a predicate on the columns of the Cartesian product of R and S. So this is a cool symbol, but all it means is this, is to do a Cartesian product of the two relations, then select which rows you want to have in the final result with your predicate here. Pretty simple. I mean, so this, you'll see this in computer science, people talking about this with programming languages. So basically this bow tie operator is what we would call syntactic sugar. It doesn't give us any additional power mathematically. It is merely a means to sort of save some writing. So rather than writing out the long form, you can do, all I gotta do is show you that I'm doing this join operation. I don't like it. Why don't I like it? I don't like it because I find this is a wonderful reminder to me of what this means. So when people write this, you have to think, oh, yeah. So first I take the Cartesian product, then I select. When you write this, all you have to do is read it. Oh yeah, parentheses inside of there. Yeah, I'm first gonna take the Cartesian product of those, and now I've got that Cartesian product. Oh, what am I gonna do? Oh, I'm going to select based upon this predicate. What are the resulting rows? That, I tell you, it spells out exactly what to do. I like it. I like it a lot. That's what I've written here. This is one of those things that I feel is created. I mean, sure, it perhaps once you have truly come to live and breathe your database world, you're like, oh yeah, that's a join. Of course, that's a join. But for, and so this is probably better for you eventually. But as you're learning, I find this far more instructive. One of the issues that I have with learning SQL or SQL is that a lot of times in a lot of books skip over that a join is really a Cartesian product with a selecting the rows that should match and meets the criteria for the final result. It's just, they just say, oh, we're joining the tables. And it's like, what does he mean by that? This is what it means. And so it's good to know it. So if you ever see this, you know what it means. You are allowed to use this in solutions or on an exam. We'll know what it means. That's fine. But you don't need to be able to work with this. This is what you need to be able to really know that this is how I basically join tables. I do a Cartesian product, and then I apply my select with its predicate. All right. Now with that, yesterday in tutorial, you saw the natural join. Okay. Natural join, I want to note, in the 7th edition of text, and perhaps Lexa was working or had seen the 6th edition, which was out when she took 342. But the 7th edition of the text is only, you really have to look to find it, is only briefly mentioned. And in fact, it's mentioned basically with a caution. And I wholeheartedly agree with the book in that. And that's a really nice revision they've made going from the 6th edition to the 7th edition, which is let's basically stop dealing with and talking about the natural join. I don't like about it is implicit versus explicit. So it's implicit in that the natural join works on column names and two tables having the same name, and those being the columns that you want to join on. So you always have to go back and look at the tables, check all the names, compare, make sure that those are the right ones to join on, and so forth and so on. The book warns that from a maintenance standpoint, people could change the name of columns and then break queries. Well, of course, that could happen anytime, but they could also add columns, and then the join would start to use those columns if they were in both tables, and that could be non-desirable. That also would break things. The thing is, I like expressing things that are explicit. That's why I was telling you, I like writing out the Cartesian product and a select. It's really explicit what's going on. Natural joins are implicit. And you can see from the questions we got in Campus Wire how confusing they are. So I think this lack of being explicit is bad, and I'll just say it flat out. I dislike it. I dislike the natural join. Bleh. 2, what else do you need to know? Well, basically cannot use in Rails. Now, that's not saying that if you had a database that was designed around the idea of natural joins, you couldn't do natural joins in Rails. That's not the case. The case is if you design a database following typical Rails conventions with naming of things, you will not be doing any natural joins. And so this is, again, the notion is that when we have foreign keys in Rails, we almost always name them original table _ID. And the primary key in the original table is just ID. So we end up with, we might have a relation where we have, students, and in students we have a primary key of ID. And then in another table, like following the book, takes or whatever, we've got a whole bunch of stuff. And we're not going to use ID here. We're going to use student _ID. So in Rails, when we've got a foreign key, we almost always go and name it in the singular of the original table _ID, where in the original table, the primary key was an ID. All of a sudden, so when you want to join these two tables, you cannot do the natural join. You have to specify, I want to join them where students.id is equal to takes.student.id. Student _ID. So what's the stupid point of natural join? In other words, I don't, let me put its nail in the coffin. All right, this is what students really want to know, is that I will never test you on natural join. I'll try to avoid having it in the homework, but I might make a mistake. But I won't test you on natural join. So the tests that we have in the course, I will not have any natural joins. And so now most of you can go, whew, I don't care. I don't really need to know about it. And then you're going to say, why the heck did you talk about them in tutorial? That was a miscommunication on my part. I thought it would be useful for Lexa to illustrate and talk about the join operator and how it is just really the Cartesian product and a select. Instead, Lexa talked about natural join, which uses the bow tie operator without any predicate, which is not really what I wanted to happen, which is my fault. I didn't make sure to express that it needed to be the bow tie operator with the predicate, which is our notion of the join operation. So that's my fault. But you did get to see now the natural join. So it's sort of an extra tidbit, but again, I wouldn't go around using it personally. And yeah, in a lot of cases, you're not going to use it. This book, though, it likes to use a lot of keys, primary keys that are based upon the data that's found actually in, so it uses, does things like names of stuff and whatever, and it uses them as keys. In Rails, you're going to see that when we get there, it follows a philosophy much more of using surrogate keys, where we always are using a artificial key, an ID, for all of our rows to identify them. There are advantages and disadvantages of this, and we'll talk about it when we get to that. So what happens is when you read the database textbook, you'll see all these schemas, the databases that they've put together, and they're largely designed to actually let you do lots of natural joins. The authors it's designed with that in mind. There's different design choices. That's part of this course, to talk about those design choices. We haven't got into database design yet. We're going to get there. Anyways, so that's the join operation, and that's me saying, don't worry about the natural join, and it's got issues anyways. All right.